Imagine a computer so powerful that it could solve problems in seconds, problems that would stump even the fastest machines we have today. These are problems that would take a normal computer, well, billions of years to crack, if they could solve them at all. This isn't science fiction, it's actually the promise of quantum computing, a technology that could change everything about how we process information. Quantum computers are a completely new type of computer, unlike anything we've built before. They use the bizarre and counterintuitive rules of quantum mechanics to store and process information in ways that seem almost magical. Quantum mechanics is the study of how tiny particles behave, particles so small we can't even see them with a regular microscope. And at these tiny scales, the universe gets very strange. Particles can be in two places at once, or even seem to communicate instantly across distances. Normal computers use bits, which are like tiny switches that can be either on or off, representing 1 or 0. Quantum computers use qubits, which are much weirder and more powerful. Qubits can be 1, 0, or both at the same time, thanks to a phenomenon called superposition. This both at the same time state is what makes quantum computers so powerful. By harnessing these quantum effects, we can potentially solve problems that are impossible for even the most powerful classical computers, opening up a whole new world of possibilities for science, medicine, and technology.
Subscribe to the channel. Thank you, Smile.
To understand quantum computers, we need to take a trip into the weird and wonderful world of quantum mechanics, a place where our everyday logic simply doesn't apply. The quantum world is the world of atoms and the particles within them, a realm so tiny that it's invisible to the naked eye and behaves in ways that seem impossible. Here, the rules of physics, the rules we are familiar with in our daily lives, break down and are replaced by a new set of bizarre principles.
Thank you, Smile.
One of the strangest things about the quantum world is that particles can act like waves, blurring the line between what we think of as solid objects and energy. Imagine a tiny marble rolling towards two slits. In the normal world, it goes through one slit or the other, just as you'd expect from any small object. But in the quantum world, the marble acts like a wave, going through both slits at the same time. This is called superposition, and it's one of the key ideas behind quantum computing. Another strange phenomenon is entanglement, where two particles become mysteriously linked, no matter how far apart they are. Imagine two of our marbles. They are linked somehow, so that whatever happens to one instantly affects the other. If one is spinning clockwise, we know instantly the other must be spinning anti-clockwise, even if they're separated by a huge distance. This link, this entanglement, holds even if the marbles are light years apart. It's as if the universe itself is playing by a different set of rules, rules that are both strange and wonderful. Quantum computers take advantage of these strange quantum effects. They use qubits, which can be in a superposition, like our wave marble, being 0 and 1 at the same time. This is unlike a bit in your phone or laptop, which can only be either a 0 or a 1. Think of a coin spinning in the air.
Thank you, Smile.
It's not heads, it's not tails, it's both at the same time. That's superposition. When we measure the qubit, forcing the coin to land, it becomes either a 0 or a 1. Entanglement lets us link qubits together. Imagine 100 spinning coins all linked. Changing one instantly changes the others in predictable ways. This interconnectedness gives quantum computers their immense power. What could we do with such powerful machines? The possibilities are honestly just breathtaking. One area is cryptography. Modern encryption relies on complex mathematical problems that are, well, pretty difficult for classical computers to solve. Quantum computers could crack these codes in a flash, revolutionizing security and privacy. Drug discovery is another exciting area. Quantum computers could simulate molecules with incredible accuracy. This could lead to the development of new drugs and treatments for diseases. The power of quantum computers also extends to materials science. By simulating materials at the atomic level, we could discover new materials with incredible properties, paving the way for technological leaps in energy, transportation, and more. So, why don't we have quantum computers on our desks yet? Because building them is, honestly, incredibly difficult. One of the biggest challenges is decoherence. Remember our spinning coin? The slightest disturbance from the outside world, like a vibration or a change in temperature, can cause it to collapse to heads or tails too soon. This loss of superposition, called decoherence, causes errors in calculations. Building quantum computers that are large and stable enough to be useful is a huge engineering challenge, requiring extremely cold temperatures and perfect isolation to protect the delicate qubits. The idea of quantum computing emerged in the 1980s. Physicist Paul Benioff is credited with first describing a quantum mechanical model of a computer. Richard Feynman, famous for his work on quantum electrodynamics, later argued that quantum computers could simulate complex quantum systems, something classical computers really struggled with. A major breakthrough came in 1994 when Peter Shor developed a quantum algorithm that could factor large numbers exponentially faster than any known classical algorithm. This discovery ignited the field, as factoring large numbers is the basis of many encryption methods. Since then, progress has been rapid. Companies like Google, IBM, and Microsoft, along with numerous startups and universities, are racing to build practical quantum computers. We are still in the early days of quantum computing. The technology is just beginning to emerge from the realm of theory and into practical experimentation, and the journey ahead is both challenging and thrilling. The quantum computers we have today are experimental and, honestly, prone to errors. They require extremely controlled environments and are sensitive to even the slightest disturbances, making them difficult to operate reliably. But the progress made in recent years is undeniable. Researchers around the world are making breakthroughs at a rapid pace, pushing the boundaries of what's possible. In 2019, Google claimed to have achieved quantum supremacy with their 53-qubit Sycamore processor, a landmark moment in the field. This meant that it performed a specific calculation faster than any classical computer could, demonstrating the unique power of quantum technology. While this was a significant milestone, it was only a small step towards building truly useful quantum computers. There is still a long way to go before these machines can solve real-world problems. The future of quantum computing is brimming with possibilities. As the technology matures, it could transform industries and change the way we approach complex challenges. It has the potential to revolutionize medicine, materials science, artificial intelligence, and many other fields, unlocking solutions that were once thought impossible. And while there are significant challenges ahead, the quest to build these powerful machines is one of the most exciting scientific endeavors of our time. The next chapter in computing is just beginning. Imagine a world where humanity's legacy is nothing but silent ruins, slowly reclaimed by nature. Picture the cities we once filled with laughter and life, now empty and overgrown, their streets echoing only with the wind, the playgrounds where children played, the homes where families gathered, all left behind as reminders of a vanished civilization. Nature, patient and persistent, would gradually erase the marks of our existence, covering concrete with moss and vines, turning skyscrapers into hollow monuments to what once was. This is the chilling reality of human extinction, the complete disappearance of our species from the planet. It's not just about empty cities or silent towns. It's about the end of every human story, every hope, every connection that once defined us. The world would continue, but without us, our culture, our inventions, and our dreams would fade into obscurity. It's not just the loss of billions of lives, but the abrupt end of our collective journey. Our art, our music, our literature, all the things that made us uniquely human, would be left to decay, unappreciated and forgotten. The stories we told, the discoveries we made, and the dreams we chased would vanish, leaving only traces for the world to remember. While unsettling, confronting this possibility is crucial. It forces us to reflect on what truly matters and what we want our legacy to be. Facing the idea of extinction isn't about giving in to fear, it's about understanding the stakes and appreciating the fragility of our existence. We face existential threats that could push us to the brink: climate change, pandemics, nuclear war, and more. These dangers are real, and ignoring them could have irreversible consequences. But by acknowledging them, we empower ourselves to act, to protect what we value most. Our future remains unwritten, and it depends on the choices we make today. By coming together, learning from our past and making wise decisions, we can ensure that humanity's story continues, filled with hope, creativity, and resilience for generations to come. Humanity stands at a crossroads, confronted by four immense and interconnected threats: climate change, nuclear war, pandemics, and asteroid impacts. Each of these dangers has the potential to reshape our world in profound and lasting ways, challenging not only our societies but the very future of life on Earth. Climate change is already transforming our planet. Rising sea levels swallow coastlines, while extreme weather events like hurricanes, floods, and wildfires become more frequent and severe. Droughts threaten food security, and entire ecosystems are being disrupted, putting countless species at risk. The effects are global, touching every continent and community, and demanding urgent action from all of us. Meanwhile, the threat of nuclear war remains ever present. Thousands of nuclear weapons are still maintained on high alert, ready to launch at a moment's notice. A single miscalculation or accident could unleash devastation on a scale never before seen, with consequences that would echo for generations. The risk is not just theoretical, it is a daily reality. Pandemics too can emerge suddenly and spread rapidly across the globe. As we have seen in recent years, new diseases can overwhelm healthcare systems, disrupt economies, and change the way we live almost overnight. The interconnectedness of our world means that no country is truly isolated from these biological threats. And while asteroid impacts are rare, their potential for destruction is immense. A large asteroid striking Earth could cause mass extinctions, trigger global climate upheaval, and threaten the survival of humanity itself. Scientists around the world work tirelessly to monitor the skies, but the risk, however small, remains. These dangers are not distant possibilities. They are real and present challenges. They threaten not just our way of life, but the very survival of our species. Understanding and addressing these risks is one of the greatest responsibilities of our time. These threats aren't distant possibilities. They're shaping our world right now. Climate change brings heat waves, wildfires, and rising seas, displacing millions. Thousands of nuclear weapons remain ready to launch, making peace fragile. The COVID-19 pandemic revealed how vulnerable our interconnected world is. Even asteroids, though rare, have changed Earth's history before. These are not just hypotheticals, they're urgent realities. Our survival depends on how we respond to these challenges. Around the world, scientists are sounding the alarm. If we want to prevent the unthinkable, human extinction, we must act now. Their warnings are not just theoretical, they are based on decades of research, data, and real-world observations. The risks we face are unprecedented, but so are the opportunities to change course. Scientists emphasize that the choices we make today will determine the fate of future generations. One of the most urgent steps is transitioning to renewable energy sources and drastically cutting greenhouse gas emissions. This shift is vital to slow the pace of climate change, which threatens ecosystems, food security, and the stability of societies worldwide. By investing in clean technologies and rethinking how we produce and consume energy, we can protect the planet and create a more sustainable future for all. Another critical area is nuclear disarmament. Reducing global arsenals and working toward the elimination of nuclear weapons are essential steps to avoid catastrophic conflict. International cooperation, trust building, and transparent treaties are key to making the world safer and ensuring that nuclear weapons never threaten humanity's survival. Scientists also stress the importance of pandemic preparedness. This means investing in early warning systems, developing vaccines quickly, and building strong health infrastructures that can respond to outbreaks. By learning from past pandemics and staying vigilant, we can save countless lives and prevent future global health crises. Planetary defense is another growing concern. Tracking and deflecting asteroids that could impact Earth is no longer science fiction. It's a real and urgent priority. Space agencies and astronomers are working together to develop technologies that can protect our planet from these rare but devastating threats. The message from the scientific community is clear. Every moment we delay, the risks grow larger and the solutions become harder. Time is not on our side, and the window for effective action is closing rapidly. But there is hope. Swift, decisive action, guided by science and supported by global cooperation, is our best chance to secure a safe, thriving future for generations to come. The responsibility is ours, and the time to act is now. Earth's history is marked by both resilience and extinction. The dinosaurs vanished after an asteroid impact, showing how quickly life can change. The passenger pigeon, once abundant, disappeared due to human actions. The golden toad's extinction highlights species' vulnerability to environmental shifts. These stories remind us extinction is real and even dominant species can vanish. We must learn from these losses to avoid repeating them ourselves. We are not powerless. Our actions can shape humanity's future. Combating climate change means cutting emissions and supporting sustainable solutions. Nuclear disarmament requires global cooperation and a commitment to peace. Strengthening pandemic defenses involves investing in health systems and research. Advancing planetary defense means supporting asteroid detection and deflection efforts. The challenges are daunting but not insurmountable. Through innovation and collaboration, we can ensure humanity thrives. The road ahead is challenging, but it's one we must travel for future generations. Let's act not out of fear, but out of hope and responsibility for our planet. Every challenge is an opportunity to innovate and build a better world. The fate of humanity is in our hands. Let's choose to act boldly. The time for action is now. Imagine a computer so powerful that it could solve problems in seconds, problems that would stump even the fastest machines we have today. These are problems that would take a normal computer, well, billions of years to crack, if they could solve them at all. This isn't science fiction, it's actually the promise of quantum computing, a technology that could change